All right, let's try some Leetcode. Here we go. Minimize myself. We're doing the trees right now, so I'm gonna kind of try to randomize it and pick a medium, right? So let's do this. Okay. Here, here's the closest medium that is not locked. Okay. Lowest common ancestor of a binary tree. Let's see what happens. All right. So number 236, lowest common ancestor of a binary tree. Given a binary tree, find the lowest common ancestor. Okay, I'm gonna have to think about what that actually means. Of two given nodes in a tree. That's probably where they meet, right? I'm not gonna read the rest of the problem. I'm gonna speculate for a second. Like, for example, if I'm given this node and this node, the lowest common ancestor is probably this 5, or like this node and this 4 is probably 5, I'm guessing. Okay, according to the definition of lowest common ancestor, the lowest common ancestor is defined between two nodes, P and Q, okay, P and Q, as the lowest node in T, in the tree, that has both P and Q as descendants. Yep, so like this node here has a descendant of 6, and it also has a descendant of 4. So this is P, this is Q. Okay, where we allow a node to be a descendant of itself. So, for example, 6 and 5, the lowest common ancestor will be 5, because 5 is the ancestor of itself and of 6, or like 6 is an ancestor of 5. I think that will be correct. Hopefully one of the answers in. Okay, so this one, 1 and 2, doesn't really show a graph of it, unfortunately. I was hoping that we would get more clarity of that point. So 1 and 2, the output is 1, so like the parent, okay. So how am I planning on accomplishing this? I have P, I have Q. Are these values or are they... No, they have to be nodes, right? Oh, I can look right here. Okay, so P and Q are nodes, okay? I guess the other question that I have is, can I guarantee that there's always going to be a tree? The number of nodes in the tree is 2 to big number, okay? The value can be anything. We don't care about that. All of the values are unique, okay? P does not equal Q, so they can't be the same node. It can't be like, whatever, 3 and 3. Okay, P and Q will exist in the tree. All right, so obviously we have a tree, which means we need to traverse it. Okay, so we have multiple different ways of traversing a tree: depth first search, breadth first search, etc. I'm thinking what I can do. So there's other ways, like, for example, we have recursion and using a stack to perform this traversal, right? So which one would be good? Well, I think it has to do... Okay, I think I see what's going on. Or I think I see a path forward. Like, I can come here and I can traverse, right? And as I pop back up, I can find for example, let's say that the node is 6 and 4, right? That was the example. I come here and I traverse, and then I pop back up, right? And when I pop back up, I can pass the information, like, hey, I found one of the nodes, right? Now at 5, I'm still going to say like, okay, well, I haven't found both nodes, but I still need to traverse my left. So I'm going to go down left, I'm going to come down here, and then I'm going to pop back up. Now this, when I pop back up, I still haven't found anything. So that is not, when I pop up to this node in here, it's not going to see that anything was found. Then I'm going to come down here and say, oh, I found it. So when I pop back up, I'm going to say, oh, I found this Q, right? This one's Q. And then I'm going to pop back up and say, hey, Q has been found. And now all of a sudden, my left and my right both say that they have found, like both of the nodes have been found. And therefore, I can set this one as my like answer. So how do I want to do this? Okay, so I should do something like traverse, okay, node. How am I going to pass it up? I don't know quite yet. I need something like answer is going to be equal to none. Okay. And now I want to find my base case. Okay, so what is the base case? Is going to be if not node return. Okay, so if I don't have anything, if I'm not a node, I just return. Now, if I am a node, I want to go left and right. Okay. So, traverse node dot left and traverse node dot right. Okay, and I need to capture the information somehow. I mean, I could have something like this. P found is equal to false. Okay, a Q found is equal to false. Okay, and then what I can do here is say if node is equal to P found is equal to true. Okay, else elif node is equal to Q. Okay, and we can say elif because we know that P and Q are not going to be the same. Q found is equal to true. Okay, well, does that... And then maybe what I can once I've traversed all the way down and I come back up, I say if P found and Q found and not answer equals node. Oh, I don't know if this is going to work. Okay, so I'm going to call the traverse and I'm going to call it on root right there. Okay, root. Okay, and then return answer. And what I think I'm doing, like here, this is, I only want to do it on the first time that this condition becomes true. No, that's not actually going to, that's not going to work, because think about this. I'm gonna come here, I'm gonna come here, I'm gonna come here and say P found. Hey, P has been found. I'm gonna set that variable. Then I'm gonna pop up, then I'm gonna come here, I'm gonna come here, I'm gonna come here, and then I'm gonna come here and say Q found. I'm gonna try to come here, I'm gonna try to come here. Both are going to immediately come back, right? Then I'm gonna hit this line, P is found and Q is found. And answer has not yet been set. So I'm gonna set it as what? As 4. That's not the way we wanna do it. Is it guaranteed that it will be coming from like a left and a right? Let me just prove that this doesn't work. Let me just like prove that. P found. Okay, well it doesn't even like. Maybe I have to go do all those self things. It's like. Okay. Let's see, did that fix the problem? Okay, so yeah, it didn't get the right answer. Yeah, so that's what I was expecting. So now I need to figure out how can I pass information up. So I have to capture it in some way, right? Like left result is equal to here, right result is equal to here. Okay. Now what information would allow me to just gonna delete all this. So what information would I hope to get? I'm in 5. I hope to get this could be P or Q, right? And I want to say that like maybe I need to pass up that not just both have been found, but they've been found in my lineage, right? So I need to return something, and okay, let me just think about this. Return what? left result can I do like a tuple or something like right result like this, and then I need to say like P found, Q found. Okay. So these two are going to be in means I'm going to be passing it up to the next layer above me. And it's going to be false at the beginning, and then I only want to change it if it has been the case that my descendants found P and Q. So P found equals false, Q found equals false, okay? And then I'm going to get this. This will be like a tuple, right? And then I'm going to say P found is equal to left result indexed at the 0th one. Okay. So this should be true or false. But then I want or right result, or why is this? Oh, Python. There we go. Or, and this will be indexed at 0. Okay, or what? Or if I'm currently at P. So if node is equal to P. So what I'm trying to do is I'm trying to say like, okay, well, I'm at this node here, this 4. Okay, I set P found and Q found to 0 or to false. Come here, I come here. And then I'm going to pass up some information. What information am I going to say? Well, I don't want to pass up that Q has been found. Or which one did we say this one? This one's P, this one's Q. So I don't want to pass up that P has been found from here, right? I don't want to pass that up here because on this lineage, P has not yet been found. But I do want to pass up that Q has been found. So I want to say like, well, does my left lineage have P? Or does my right lineage have P? Or am I myself P? All three of those are no, so I'm going to pass up no to P. Now, Q, remember this is Q. Is my left lineage have Q? No. Does my right lineage have Q? No. Am I Q? Yes. So now I want to pass up here that Q has been found. So now this one's going to come and say, well, my left doesn't have P, my right doesn't have P, okay, and I am not P myself, okay. So P found is false. Then I'm going to come here, my left does not contain Q, but my right passed up that Q is there. That's going to be this one. Or, well, actually, it's going to be right result, and then indexed at 1, because that's 1 is Q found. So then that's going to pass up as true. So then we're going to pass up, okay, well, Q found is in my lineage. So then we're going to get here. This one's going to say P is found. This one's going to say Q is found, and then we're going to be happy because both lineages have that they found P and they found Q. So we're going to do the exact same thing here. So Q found is going to be equal to left result, and then we want to index it as the first one, right? So this is the 0th one, this is the first one. That's Q found. 1 or right result indexed at 1 or node is equal to Q. Okay. So now what I want to do is I want to check if this answer is, if we need to change the answer. So only if both in my descendants, so if P and Q have been found. So if Q found and P found and not self.answer, okay, so, and I haven't found an answer yet, then what do I want to do? Then I want to do self.answer is equal to node. Okay. Let's see if that works. Oh. Okay. What is it complaining about? Node type object has no attribute get item. Node is node here. Do we have to go like node.val? Is it? Okay, whatever. And am I returning? It says I'm returning a tree type, so I'm not sure if that what exactly it wants. All right. Well, what does it not like? None type object has no. Oh, return false. Okay. Is that what it's asking? Oh, I don't know. Hey. Ooh, I like that. Let's press it. Come on. Yes. Okay. There we go. Got it. Now, second part of this is, okay, let's go and check the answers that other people did and see if I was on the right track of, looking from this, I think like, okay, well, I didn't do a wildly inefficient solution, but I always want to see like, okay, well, how are other people going about this? Make sure I'm doing reasonably. Okay, so let's look at this. So if not root, or root is equal to P, or root is equal to Q, return root. Okay. So now, left and right, lowest common ancestor. So he's passing in So it's recursive to the function itself. I did a traverse helper function. Okay, it's fine. Passing in the left as the root, and then P and Q are remaining the same. So we're traversing down the left path, and then down here we're traversing down the right path. Okay, if left and right, return root. Okay. So return itself. If return left, if left, else right. Okay, how is this working? Okay. The idea is to traverse the tree to find the node where both Q or P and Q split into different subtrees. That node is the lowest common ancestor. We use post-order traversal to return on both sides, have non-null results. Okay, so base case is if root is null, return null. Okay, if root is equal to P or Q, return root. Like, So if we found P or Q, then we return the new node that we're on. Recursively check if left and right subtrees. If both are non-null, current node is... Oh, okay. Only if one is non-null, propagate it upwards. Okay, so that's why they're doing if left and right. So if both of these are non-null, then we know that this node is the lowest common ancestor because both our left and our right have something, whereas if they don't have P or Q, it's going to be null. Is that right though? If not root, because here we're returning root. So it seems like root is going to be non-null no matter what, right? Like, under which conditions would would the return value actually be null? If left and right, return root. Otherwise, we return left, which is not null. If left, else right. Okay. Well, I don't think I did anything. I think I was on the right track. This person did it in a slightly different way. Maybe I'm a little bit too tired right now to think of their solution, or I don't know. I like how I just blame it on being tired. I'm tired. It's not my problem. I'm not bad at reading code. No. I'm just tired. Okay. So, anyways, the real is maybe I'm just not very good at reading code. Maybe I'm just who knows. But anyways, I like how I automatically just try to squeeze that in there, right? Like, okay, well, there's why. Find an excuse. No, I should take responsibility. I need to improve my code reading ability. But I'm happy that I think I was on the right track. Or I should say, obviously, I was on the right track. I was able to get it. But what I mean is, I think both of us this person and me are on the similar track. So they didn't use some other methodology that I just didn't even think of, because that's kind of what I'm hoping is to be able to see, like, okay, well, number one, am I able to solve it? And then if I'm able to solve it, okay, well, are there other interesting ways of solving it, or did I solve it in a suboptimal way? And then how can I iteratively improve on that? So I think in this problem, I was able to find the solution, think of the solution, and code it out. So I'm very satisfied with the results of today. So yeah, I hope you guys enjoyed this video. If you did, subscribe, and I will be back for more Leetcoding videos in the near future if you so desire. So yeah, I will see you guys later. My name is Timothy Lee Grant, and have a good rest of the day.